In today's lecture, we'll see another library that's commonly used in Python. So that's library named matplotlib. Okay, or basically it's a library for plotting of graphs. Okay, graphs and such figures. So we can use matplotlib to plot the graph or to show some graphical representations. Okay, so for importing the mat library, what we have to do is we have to the main library is called pyplot, and from pyplot we are using only the matplotlib. Okay, sorry, the other way. Okay, so from matplotlib we are importing the pyplot library, and we are naming or we are giving an alias as plt. Okay, so from matplotlib import pyplot as plt, and yeah, let's first create an array here. Okay, so we are creating a numpy array. You can pass numpy array, python list, etc. directly to this function for plotting the graph. That's fine, but by habit I am using numpy array only. Okay, so here I'm giving the values as 1 2 3 4 5. Okay, so my array named x that has the values 1 2 3 4 and 5. Okay, and now I'm defining a new variable y. Okay, so here remember that x is a numpy array. Okay, right, so here I could not have used list because I cannot use this particular line if I'm using a list. Okay, so 2 into list won't give you what you need, right? So this was a, or this is a numpy array. So because of that, when I write 2 into x, all my elements in that array, that is 1 2 3 4 5, that get multiplied with 2, and then after that 5 will be added to each of that element. Okay, so basically I'm creating a function y equal to 2x plus 5. Okay, and the value of x is 1 2 3 4 and 5, right? So this will be a straight line, or this should be a straight line, because y equal to mx plus c is a equation for a straight line with slope equal to in this case slope equal to 2 and intercept equal to 5, right? So I'm just printing the value of y here so that you can see that the calculations are correct. And then for plotting, the function is quite simple. We just write plt. So because we named it as plt, then plt dot plot. So that's a function for plotting the graph. Okay, then you give what's in the x-axis and then what is in the y-axis, and this is a optional variable. So what I'm giving is I'm saying I'm using the alphabet R. It means the graph color should be red, and then the points should be marked with a circle, and then I'm giving like comma comma, or sorry, minus minus. That means the line should be dotted line. Okay, so if I run this code, so first of all, that array is printed 7 9 11 13 and 15. So that's my y. Okay, and then you can see you have to give another line also, plt dot show. In collab, if you don't give that also, still you will get the image, but if you're using any other program to write python code, you must write plt dot show also to see the graph. Okay, so here you can see the color of the graph is red. We have circles denoting the point, and then we have a dotted line connecting the points. Okay, suppose I don't need the line at all, I just need the points, then I can just write ro, and then the points will be the graph will be plotted without a line. Okay, if I need a straight line without the dots, then I just put 1 minus, I get a line. Okay, if I need to change the color, it's quite intuitive. So if I need green, I can just write G, and here I have a green graph. Okay, if I need to change the marker, okay, if I need to use, let's say, like a star, like an asterisk, if I do that, I get the marker changed to asterisk. There are other different markers also, and like a whole lot of them. So if you want, you can just Google what do you say, matplotlib markers, colors, or something like that, you get all the possible options that you can use. Okay, so here I just used some triangle markers. Okay, so you can just keep changing or playing with that. Yeah, right. So this is basically how you plot a graph using matplotlib. You just give the values on the x-axis, you give the values on the y-axis, and then this is entirely optional. Okay, so if I just delete that also, still I will get a image, or I must get the image, right? Okay, yeah, so here I am just getting a blue line. Okay, but yeah, for more readability and for more aesthetic purpose, you can just use whatever you prefer to use. Okay, so right, fine. So that's basic about plotting a graph. We can see more examples, and here I'm just using another numpy function for creating an array. So that function is known as like arrange, or a range actually. And then I'm creating an array here and just printing it for you. You can see what a range does. So what happened is, it like creates an array starting from -10, and it goes up to um, plus 10. Okay, so that's why I gave the number 11, because 11 won't be included. Okay, and so that's my x now, and here I am creating another variable y. So y equal to 4x square. Okay, so basically that should be a parabola. Okay, we have y equal to 4x square. That's the equation for a parabola, and I'm just printing the value of y also, so that you can see. So the yeah, all values of y should be positive, because we are doing x square there. Okay, and then I'm just plotting the x comma y. So you can see that we are getting this parabola with the vertex at 0, right? So that was the equation for the parabola only. Here I didn't give any marker. I can give any marker if I need. Let's say I prefer black color, and then I prefer circles and dotted line. Okay, so black color, actually B won't be good, because B is for blue color, so black had to get the alphabet K. Okay, so yeah, here you can see like black dotted lines with black markers. Okay, and there are lot of things you can use or change here in matplotlib. Like you can change the values that are printed here, or on the x-axis or the y-axis. You can change the spacing, etc. Okay, for all that you can simply google, and you can see how different formatting is possible. Okay, and now here we'll just plot another function, and I'll just include some more functionalities in matplotlib. So just run the code first, and then I'll explain. Okay, so here this is the graph I'm getting now. Okay, and let's see the code, and then we'll come to the graph again. So here I'm writing x equal to np dot arrange, starts from 0 and goes up to 5 into np.pi. Okay, so that's the pi value, right? You know the pi 3.14, right? So that value we can have, instead of writing 3.14, I can use np.pi. Okay, numpy has this yeah, variable pi inbuilt into it. So I'm writing 5 times pi. Okay, because I'm going to plot the graph of sine and cosine functions. Okay, so I need the values in radians, right? So the my x contains radians 0 to 5 pi, and this point one, it is just the incrementing. Okay, how many like from 0 to 5 pi, how many in what increment I should increase the value. Okay, that's for getting like larger numbers. Okay, and here I'm creating another variable y underscore sine, and that stores the value. So numpy again has this function sine, and if I just write np dot sine of x, then all the values of x will be taken, and the sine of that value will be taken and stored to y underscore sine. Okay, similarly y cos has all the values of cosine function, right? And now I'm plotting both of them. Okay, previously we had just plotted one set of data. We had only one xy, but here I'm doing two plots. Okay, the first one has x at the values of, from 0 to 5 pi in the x-axis, and the value of corresponding sine function. Okay, and here I'm using red line and red dotted lines. Okay, here I have given additional label or additional argument label equal to sine. Okay, so that's because I want to show that I want to give it this legend over here. Okay, saying that the red line correspond to sine. And similarly plt dot plot for the cosine function also, and here I'm using green dotted lines and I'm giving the label as cosine. Okay, and now if you just give the label, it won't be printed here. You need to use this function plt dot legend, and we have to mention where to place the legend. Okay, so these arguments are for that. So here the location, that's loc equal to best, means the program itself tries to determine which is the best position for placing the legend. Okay, and then this is again, both of them are optional only. If you don't give this lock and box to anchor also, the legend will come up. Okay, we can actually see it what happens. So I'm just commenting out that line. Sorry, but if I don't type that name, that won't come. Okay, so here we don't have any legend at all, but let's just give this one line of code, plt dot legend. Okay, so plt dot legend and running it, and you can see the result now. Yeah, so here the legend is placed at this left bottom corner. Okay, so I can change the location, like I can write just like lock equal to uh, upper left, let's say. Okay, and if I just run it, you can see it came to upper left. Okay, so you don't have to by heart all this actually. Whenever in doubt, just use Google. Okay, and yeah, but here, like in this particular function, wherever I place this legend inside the box, this legend always covers some portion of the graph, right? So it's better to place it outside. So that's why we are using this second argument called box to anchor. Okay, so this actually is in reference with the x and y coordinate. If I write 1 here, that means the maximum value of y. Okay, and if I write 1.05 means maximum value of x plus 5%. Okay, so that basically places my box at this position, maximum of y and maximum of x plus 5% of x. Okay, so if I write 0 here, that will come at this point. Okay, 0 of y and x 1.05 times the maximum. Okay, so yeah, that's for placing the legend. And then I'm giving this x label, okay, as angle. Okay, so here I have to give the like x-axis a label. Okay, so I'm just giving the angle, and then plt.y label, it's for the labeling y-axis. So we have trigonometric value as the y label. And if you need to give a title, okay, so plt.title, that gives a title for your graph. So that is graph of sine and cosine function, and then plt.show. Okay, so that should show your graph. Okay, and if you want to save the file, it's again plt.save figure, or save fig actually, and here you have to give a file name. Okay, so abc dot with the extension. Okay, so abc.png or abc.jpg, that all works. Okay, so you can, but you must specify the extension in which the file have to be saved. Okay, and if you're working in collab, yeah, please note that your file will be saved in your Google Drive location only. Okay, so actually that how to access that file and how to access a file from Google Drive in your program, etc., we will deal it in the next video. Okay, so for the time being we can stop the video, and yeah, see you in the next video.